Hi guys, today we're going to go over lesson 2, 5 deductive systems. And this is a really short lesson. And as you're probably finding, this textbook is very different from algebra textbooks. It takes just a few ideas and it makes you apply them. And so you have to use higher order thinking, and you have to also use every previous lesson that we've ever had. I know in algebra class, you learn how to factor, and then you just practice a bunch of factoring. You learn how to solve for one step equations, and then you just practice a bunch of those, and you really don't practice all the previous lessons at one time. And that's where this textbook is different. So what we're going to do is we're going to talk about the different types of reasoning. There are only two. They're inductive and deductive. Everything we've had pretty much up to this point has been deductive. It's everything logical. It's like syllogisms. And the example here shows, A to B, B to C, then A to C. That's a syllogism. That's a direct proof. So what is inductive reasoning? Inductive reasoning is more like an educated guess. All right, I hope you can read that. That's pretty messy. Okay, so if you're trying to find a pattern and coming to a conclusion, or if you're making an educated guess on something where it's not so concrete, this is inductive. So I have this little pattern here, and why don't you go ahead and pause the video and try to figure out this pattern. Okay, guys, so hopefully you figured out the pattern. If you add these two together, you get 2. If you add these two together, you get 3. If you add these two, you get 5. So if I add these two, I will get 8. If I add these two, I will get 13. So I could keep going, but that is the pattern. If you figured this out on your own, that was inductive reasoning. So as we've talked before, definitions are really important in mathematics because without them, words could have different meanings to different people, and to avoid this, dictionary makers had to get to a starting point. And those starting point words from chapter 1 was point, line, and plane. Now, for the same reason that it's impossible to find everything without going into circles, it is impossible to prove, because it's impossible to prove everything. So to avoid eventually coming back to the point in which we begin, we had to leave a few statements unproved. And these statements are called postulates. Now, postulates, here I have the definition. Did I not write it down? Okay, let's write it down. A postulate is a statement that is assumed to be true without proof. Be true without proof. Okay, so again, to avoid coming back to the point at the beginning every single time, we're just going to come up with some statements that are always assumed to be true without proof. Okay, so what we're going to do is we're going to have all these postulates for the entire year that we get to use, and they are true, but we don't prove them. Okay, so that's the point of them. And we're going to use these postulates to help us get to conclusions using deductive reasoning. Now, I know I sound like I'm talking in circles, but you'll get the hang of this. Postulates are like main rules, and we have to use those to help us get to new rules, if that makes sense. So our very first postulate is 2 points determine a line. And you guys know that. Back in chapter 1, we discussed how if you have 2 points, that's the only way you can draw one line. And if you have 1 point, that doesn't make a line. And when you name lines, how many points do you use? You use 2. So that's your very first postulate. Now you have a theorem and postulate sheet that we've talked about. You need to make sure this is on your sheet because later we're going to have so many theorems and postulates, you're going to want to reference it. And you could use that on tests and quizzes. You don't want to have to keep going back to like your online textbook. You want these on a piece of paper. So if you have already printed off your theorem sheet, fill it in. If you're doing this on your own piece of paper, write it out. You will want this. Okay, so you will use postulate 1 more later on when we do proofs. It is common. So again, You have to write this down. Can't say that enough. Postulate 2, 3 non-collinear points determine a plane. Again, we know this. How do you name a plane? You name a plane with 3 non-collinear points. So, again, a postulate, they are assumed true without proof. And when we get to theorems, theorems are like theories, right? And you have to prove those. So that's the difference between the two words. So we're going to ignore this for now. Okay. When you get later on in the book, they're going to say things like draw a C. And then you're going to look at it and people see the picture and they say, okay, I'm going to just draw it. It's not saying to draw it. The directions always say justify. Why can you justify that you're drawing a C? Well, the only way I can justify it is by postulate 1 because 2 points determine a line. So here you would say postulate 1. You're not going to physically draw it in here. You're justifying it. So that's the difference. So justify why you can draw plane ABC. Well, if you only have 2 theorems, if you only have 2 postulates, postulate 2 says 3 non-collinear points determine a plane. So you would justify it by saying postulate 2. Okay, so again, you're going to have a lot of application questions, and I made a lot of them multiple choice, so it will be easier for you to figure out by elimination. Please come to the open help sessions, and I will help you. You have unlimited attempts on your assignment, so if you don't get it the first time, ask some questions and go back and try for a better score. All right, guys, until next time, see ya.